Hello everyone, good afternoon. Hope you had a wonderful time with the previous sessions. Today we are speaking about PostgreSQL Unboxed, leveraging containerization for scalable database deployments. So to begin with, a few years back, I was working with a retail client and they had their system into the traditional architecture, that is into the monolithic application, where all their applications were into a single component, and for serving all the applications they had a single database. The current system that they had was quietly complex because of lot of interconnected applications. So in order to accommodate the growing customer needs, this was a challenge. So to overcome that, they thought of going to the microservices, where they splitted their components into multiple sub applications. So every application will serve a particular business needs, let's say order processing, customer management, etc. And as the microservices grew, the architects also thought of decoupling the database logic as well from the current application layer. And to decouple that, they had the need of provisioning multiple databases. So it was not just one DB, but they had multiple DBs based on the number of application sizes. So to do that, that's when the architecture team thought about going with the containers, and that's when containers were introduced. So just like we have containers for deploying our different applications, in the same way can we also use database as well for deploying our for deployment inside the containers, which can be a scalable as well as lightweight solution. So from here on, I would like my colleague Ramya to take on and throw a light on what containerization is. Yeah.
This one. Thanks, Shalaka. So before we dive into the solution, let's start with the basics. How many of you have worked on containers before? Okay, quite a few. For those of you who are not aware, so basically in a traditional system you have a server, and on top of server you have operating system, right? And on top of operating system you will be deploying your applications with dependencies. So what happens is, if when you are deploying it on a Windows, let's say, then you have to deploy a Windows specific app, and if you are deploying on a Linux, then it is a Linux specific app. So this is where container comes into picture. Container has something called container runtime engine. What it does is it packages your apps and dependencies into a package and called container, and with that you can deploy this container anywhere, like in any operating system, be it Linux, Windows, it doesn't matter. So this dependency of operating system is completely removed by containers. So containers, it is also lightweight. There is no other dependency as well. So this is about container. So now let's see how you can utilize container technology for deploying Postgres. Okay, so it happens in 3 simple steps. First step is you will pull Postgres image from a container registry. And second is you will load container image into runtime, then you will connect to the DB. So when we say container registry, it is a collection of repositories, images. One of the popular container registries, Docker. I am sure, like, if you have worked on containers, you would definitely have come across Docker. So Docker hub is one of the popular container registry, and we will be using Docker in our demo. So now we have established that we can run Postgres in a container, right? But for our use case, right, we want the database to be highly available. So in case if in case if that one of the instance goes down, right, you want to have a backup, you want it to be scalable. So for that, one instance is never enough. You need to have replicas. So what we are planning is, we have a primary which accepts both read and write connections, and then there are replicas which would have only read-only connections. So some of you might be aware there is PG based backup, which what it does is it consistently puts the data from primary to replica, and there are volumes attached. So this what you are seeing is a simple setup of 1 primary and 3 replica, and in our demo we will see how you can achieve the same setup in a container. Okay, so we have two folders, Postgres1 and Postgres2, okay, and we have config files, right, and the one which, can you just move backwards a bit? Yeah, so this one, please pause once. So this is HBA config, right, so authentication basically. We have replication user, which we will be creating to replicate the database from primary to replica. Go ahead. So then we have Postgres config, where we are setting the WAL level. So WAL, you might be aware, it is write ahead logging. So in Postgres, maybe you can pause a bit. So in Postgres, when you write, you write it to a transaction log and then you commit it to the database. So that's where we had defined the WAL level there. So now we are connecting a network for the Docker. So what it does is you have two containers, that's what we are planning, Postgres 1 and 2. For them to interact between themselves, we need a network. Then we are creating the first container. These are some of the commands, like we are just specifying the username, password, etc. So once it does, you can see here, database is ready to be connected. Yeah. So now we have logged into the first container, and here we are creating the user, Postgres replication user, which I just showed in the previous slide. So once the user is created, what we are now trying to do is, we are trying to run the PG based backup. Okay, before we run the PG based backup, we are creating a data volume mount for the second container. Now we are running the PG based backup with the replication user which we created. So once it does, it creates the data directory. So here you can see in Postgres 1 we have PG data, right, as well as in Postgres 2 we have PG data. So this is copied from the Postgres 1, right. So now, okay, we are exiting the container. Now what we are trying to do is, we have run the Postgres 2 actually. We created Postgres 2 from the data volume mount which we created, and it is only read only. So now you can see there are two containers, Postgres 1 and Postgres 2. Yeah, the Docker PS just showing the Postgres 1 and 2. Yeah, now we are logging into Postgres 1, which is our primary, so it can read as well as write, right. So I am trying to create a table. The table is created, just like displaying it. Now what we will try to do is, we will go into replica and see if this is present. So we will log into the second container. So the table which is created in primary container is present. Now we are trying to create, so since it is a replica, that only read-only connections are accepted. So now what I am trying to do is, I am creating second table there just to see if it is real time, right. So we created a second table, and here you can see two tables are present, and in the replica you can find the second table. So this is how, this is a simple example of having one primary and one replica, right. But now imagine if this you have to do for 50 applications, 100 applications. One replica is never enough, you need to have more, right. So what happens, like what could you think would be the challenges when you try to scale this kind of system? Anyone wants to try? Okay. So one thing is the limited orchestration. So when you are trying to scale it for 50 replicas, the manual work or the overhead is more than manual scaling. So if you had seen the config file, you have to manually go and define the replica levels, the number of replicas, etc. And when you are creating second container, you would have to create it manually. So in the same way, if you are doing for 50, 100 replicas or the containers, it would be manual. Last is the no self-healing. So basically, if one of the container goes down, there is no automatic failover. So you would have to do it manually. So these are some of the challenges that can come up when you are scaling these kind of system. So to tackle such things, what do you think we can do? Yeah, that's absolutely right. So what you said, like he said that we can use a container orchestration tool like Kubernetes. So that's one of the solution. We have many other solutions as well, but we would be discussing Kubernetes in this session. So I will hand over to Shalaka to continue with this. Yeah. Can you just give the mic?
Yeah, hi.
Yeah.
What is the main difference configuring a streaming replication in the server-to-server replica or with the container? Because I couldn't able to follow the video. So what is the main difference?
So I mean, it would be same in any environment, not just containers, right? Like establishing a streaming replication with PG-based backup is same.
Yeah.
What we are trying to do now is, we are trying to leverage container technology to deploy Postgres. That is the idea. So how do you deploy Postgres using containers with replication was the idea in the previous demo. But since we have challenges, she is trying to explore what can be done better.
Okay.
So as discussed previously by Ramya, like we are having the main challenge that is related to scaling and also related to the management and related to the high availability in case of there is any disaster happens. So for that as someone rightly said, that Kubernetes is a solution. So for those of you who are new to this, so Kubernetes is an orchestration tool that lets you manage the different containerized applications and in various different environments. And it also helps the auto scaling of the pods, like it can help in the vertical as well as horizontal auto scaling. Then Kubernetes also recovers from the failures in case if there are any interruptions whenever any container is running. So in that case, you may see that Kubernetes will automatically take the care of reprovisioning that particular container for you. So these are the features that helps Kubernetes a good choice. So for the database related deployments, we have a few components in Kubernetes that are responsible for deploying the databases within containers in Kubernetes. So just as Ramya explained, like how in Docker we can run the containers and replicate them, similarly in Kubernetes as well, we have a few components. So I would like to show the important ones. So the first one is the Kubernetes service. So let's say if I have the 3 pods. So pod is the smallest unit inside a Kubernetes cluster. So a pod is let's say having a single container in it. So there are 3 container running databases in them. So service will help these pods to communicate between themselves, and also in case if there is any every database has its different URL. So service will provide a permanent IP address for them in case they can use this to communicate with the outside network. And also the life cycle of the pod and service are not connected. In case like if any particular pod goes down, still the service will continue to accept the request, and it will the request will be handled by the other pods. So in that case the service will continue to go on. Now the second component is the config map. So in our applications we have lot of configuration files, so especially related to the database URLs. So in this case you need a central repository where if you have a lot n number of applications, using the config map you can store them in that particular file. So in the config map it acts as an external repository for your application, so all the database URLs and other URLs that can be stored. The next component is the volume. So obviously for every database to run we need a storage, and persistent volume is the component that Kubernetes uses. So volume can be either on a local machine or it can be on a remote server. So majorly for the database kind of applications, in case if any particular pod goes down, so since the volume is attached to it, using the same volume we can re-provision a different database from it, and in case of failure still the objects that are present, they will be intact. So even if the cluster is shut down or rebooted, so there will be no loss of data. Then the last component is the stateful sets. So for the deployments related to the databases, majorly we use the stateful sets. So for the applications, we have the stateless deployment, but for the databases like Postgres, MongoDB, we need stateful set. In a sense, like if we want to maintain the state of that particular DB, like what is the structure of the data, what are the objects in it. So if I want to provision the same copy of 10 DBs, I can use the same volume, persistent volume internally, and I can provision them without any hindrance to my underlying data. So these are the some of the important components that we need to remember. So just like for Docker we have different configuration files, similarly for Kubernetes these are the important components, but still you may feel like still there is a chance for improvement, right? Because there are these 4 or 5 components that you will have to individually manage and to create for the deployment purpose. So for that we have come up with the means there is a solution available, and that is the operators in Kubernetes. So how many of you have worked with operators in Kubernetes? Okay, that's a good number. So operators are just a kind of an extension to the Kubernetes components, which are helpful for the deployment management, and also they they help you to manage whatever components I have discussed previously. Operators will help to take care of them. So Postgres operators are available that you can readily use, and some of the available open source Postgres operators are like Crunchy, Zalando, Cloud Native, Move to Cube. So for this particular demo, we are making use of the Zalando Postgres operator. So this is how the actual operator works. So what happens is, like, first there will be a user will deploy a cluster manifest file. So this file is in the form of a YAML form where you will have all the configuration parameters. So this configuration will be related to your database, what kind of database you need, Postgres, the version, then how many number of instances you want to spin up. So once the user gives this file, the next step that the operator does is it will first create a operator pod. So this pod will act as a managing pod for creating the different components for you, like the operator config map, the infrastructure role, the secret, service, endpoint. So the operator pod will try to manage these things internally, and then it will also provision the number of instances that you have given in your manifest file, and if you give, let's say, 3 instances, it will try to create 3 instances for you. One will be the primary and 2 will be the replica. And also the Zalando Postgres operator also makes use of the stateful sets internally. And for the high availability, like in case you get suppose 3 instances and one goes down, it will take the case of switchover, and it will move from primary to the secondary. So the switchover is taken care by the patronym. So in the coming demo, I will be showing this process of how we can use the operator and run it in our local server to manage the instances. Yeah, so first what I am doing is, in my local machine I am trying to create a cluster for Kubernetes. So kind is the kind of utility that we use to create the cluster. Now below that I have a set of manifest files that are used for my config map, the operator, and these all components. So these files are readily available as part of the Zalando Postgres operator. We have just pulled it from the Git repo, and then we are trying to apply these files to our Kubernetes cluster. So it takes a few moments to run them. So the first one is for configuration. The next one takes care of the identity and permissions for you. The second one is for deployment, and the last one is for the API service. So there is an API that you can access through to get the cluster information from it, that we'll be seeing right now. So as you can see right now, when I run the pod status kubectl get pod command, I can see there is first container is creating, and that is my operator pod. This is the one that I was talking about in my previous slide, where the operator pod will create the other components for you. So right now it is in the, as we can see, it is now in the running state. The next thing that I am trying to do is I am trying to apply my UI file. So this is an optional feature of the operator that you can apply to access the to access the cluster information from the UI. So it is in the, as we can see, currently it is in the creating state. It takes a few moments for the UI to be up and running. Using port forwarding, now I can see that the UI is up, and yeah, so here the it shows whatever logs, so, and also it shows the YAML file, the manifest file that I was talking about earlier. Like this is the YAML definition in which you can give the kind of Postgres you want, the version, then what is the size, then what are the instances you need. So currently in this it is one instance. Right now we have not applied the create this manifest file, so we are seeing 0 pods in the UI. So now using the kubectl create manifest, so I am applying my manifest file, and once it is applied, I should be able to see the pods getting created. So as the first one, acid minimal cluster 0 is the name of the pod that I had given, and it is currently in the creating status. As we can see here in the UI as well, it has shown us that the one container is in progress. Can you do it a bit? Yeah, so in the manifest file I had given later on 3 instances, and we can see the 3 instances are getting created by the operator, and they are up and running. So as now what I am doing is I am trying to log into my first container, that is cluster 0. So there the passwords will be generated automatically for you. You just need to log into the system, and in my first container it is a master replica. I'm trying to create a table, and the table I'm able to create and as well as access it. So currently, as we are creating one master and two replicas, only one container you will be able to create, means you have the right access. So now what I am doing is I will be trying to log into my replica container and try to see if the table that I had created in my master, if it is accessible or not. So you can do a bit fast forward here. Yeah, so here as I can see that I'm trying to create a table. It doesn't allow me since it is a read-only transaction. So in replica, as expected, we cannot perform write operations, but I can able to access the table that I had created. Now I will show the switch over how it happens. So using the kubectl get pods, I can see the cluster 0 is my master, and the cluster 1 and 2, they are my replica pods currently. Now what I will do is I will try to delete my master. So using kubectl delete pods, I have deleted my master. Now I will check the status again to see what is the current master pod. So as we can see, the cluster 1 has become the master now, and the 0 and 2 have switched to replica. And also we can see, since we have given 3 already in our manifest file, the number of 3 instances is maintained by the operator for us, and there is no manual intervention required here. Now the next thing that I am checking is once I deleted my cluster 0, whether the objects that I had previously created, are they still available or not. So I am again logging into one of my, that is the cluster 0 that I had deleted now. So yeah, so as we can see, the customers table that was there is still there, and using this we can see that even if the pod has died, still the database objects have been maintained, and also the primary replica and the primary and the secondary are also up and running, even though there have been any disaster recovery kinds of scenarios. So yeah, we can go to the next slide. Yeah, so okay, yeah, so in conclusion, I would like to say the points that we had addressed in this solution. The first point is related to consistency, like using the operators in Kubernetes. We have tried to do the consistency between the different pods, like as we see, like we created 3 replicas, and even though one of the pod dies, still the data that was there, it is intact. Then for scalability, so just like we have seen for this 3 replicas, similarly what we had to do is just we had to maintain the manifest file. So similarly you can maintain n number of manifest file and you can deploy it. So you can also integrate that solution with the CI/CD, where if there are multiple teams requesting for provisioning the database instances, they can just submit this manifest file, and then an automated pipeline will work in the backend to create the instances for you. The last one is I already covered, that is automation and DevOps. And the resource efficiency is like, since we are using the containers, the teams, whatever is the required size they have for the DBs, only that much of containers and resources we are provisioning. So in that way we are also trying to eliminate the need of provisioning too high clusters that are unnecessary for us. So in this way we are also saving the resources that are required. So with that, I would like to conclude on this topic and be open if there are any questions. Yes.
So you talked about a little bit about the volumes. What was the storage backend for the volumes? Was it file-based access layer or block-based access layer? And what were the challenges, if there were, when you ran it on a performance environment? Like, did you try to run any performance for testing this cluster setup?
So basically, actually, this solution is just a generic solution that we are representing first. And second is like related to the volume. So Kubernetes doesn't maintain its own storage. So we have to define it outside. So mostly it can be within our local file system, or we can go for a cloud-based one. So whatever is as per your use case, that volume can be accommodated. And what was?
I mean, we have tested on the local file
Yes.
systems.
Yes.
Just to add, I think we tried both the options of mount point and this one, block storage, I think. So we were having a performance issue. I think we used OpenEBS. I think that's all the problem for this one. I think we tried OpenEBS. That's all the performance stuff there, because it's a block storage. Yeah, not a file system. So obviously you get a better performance in the block storage. Right. I have one question on the operators, right? So the operators, what you used, all the open source operators?
Yes.
And do you know the compatibility of which version of Postgres?
So right now we have used the version 22.0 point something. So it's compatible with that Postgres version.
So I mean, I'm using 14 and above. So is it compatible with that?
Yes. Yeah. It's a open source, so it's compatible for most of them.
Okay. Yeah.
So at the beginning of the session, you mentioned about the purpose of using containers is because of change in architecture, like going from a monolithic to microservices architecture, so that the databases are small and can be containerized. But in case if we choose to have a monolithic app and a big database which is highly transactional, very big in size, is it recommended to use containers for that kind of a workload? And my second question is, does Amazon RDS runs on container? For Amazon RDS for Postgres runs on container, or how is it running today?
So for your first question, like you mentioned, like you have a very heavy database and you have a single application. So the use case that we are talking about is when you have n number of applications, multiple applications, and you are getting lot of different kinds of read requests. That time you can have the databases in a container where you are not having that much data intensive operation, but your read request and that kind of customer use cases are more. So in that case, this solution is helpful. But in case if you have a very big data system where there is huge volume of data, then you can think of some different solutions. And to the second thing, that is Amazon RDS, for that in depth, maybe you can visit to the AWS booth for the product related more information for it.
Sure. Thank you.
Yeah, so I want to know, like, since this Zalando operator required Petroni, it's running on the Petroni. So what's your recommendation? We can use the Kubernetes etcd, or we can have our dedicated etcd on the worker nodes?
So you can, for the demo we have went with this operator. It's not like our other operators, there's no such harm. You can go for any particular operator, because I think most of them have the same functionality. In few of them there is few added functionality. So for your use case, whatever fits best, you can go with that.
Sure, thank you.
I think currently you have used 15 version, right, in the PostgreSQL. So if you want to upgrade to a higher level version and everything, so can we proceed with the minimal downtime, or how you are going to upgrade the PostgreSQL?
Yeah, so in case of a downtime or you want to upgrade it, what you can do is whatever are the replicas or the standbys that we have created, you can redirect your request to them. And that is the main reason that we are creating the replica instances, like in case if there is downtime or any upgradation required. So first on one particular replica, you can perform that upgradation, and on the other two replicas, the standby ones can be promoted and they can take the other application requests.
Okay, and
Also, I mean, the volume is external, so when the container uptime is very less when it is getting promoted to.
yeah.
400 production DBs with the land operator, so all live, and we are using since last 2 years.
Okay. Was this a question?
Okay, last
Can-
question. We'll have last question.
Okay.
I didn't understand.
If we are going to upgrade this Kubernetes, so will that be impact on the pod services also?
No, the pods, so you mean to say like if there is any upgrade in the service, will there? No.
Yep.
So in if it is application kind of deployment, in that Kubernetes has this rolling updates feature, and lot of features are there in which you can upgrade a certain set of pods first, and the certain set of pods you can keep it with the older version to accept the incoming request, and once it is stable, the new set of pod that you have upgraded, then you can switch over to your traffic accordingly to the new set of the upgraded versions. So there is no downtime as such with the features that Kubernetes provides.
And can we add SSL on this PostgreSQL Docker? So while we are going to implement this image and everything. Yeah.
So this feature we have not yet explored, but definitely we will check on that and get back to you.
Yeah. Thank you.
Okay, so with that, I would like to thank you all for giving your time, and enjoy the rest 2 days of the PG conference. Yeah, that's
Thank
all.
you.
Thank you.
Thank you so much, Ramya. And